There aren't many blockbuster academic papers. In fact, the average scholarly article is read by just about 10 people. But the latest revolution in AI can be traced to a research paper that was published in 2017 that saw the kind of viewer numbers that you'd expect from a Hollywood blockbuster. And this paper, written by 8 scientists from Google, didn't just get read. It quickly got cited in research papers all around the world, meaning others were building on this paper's new ideas.
In the history of, I think, a scholarly publication, is one of the most cited papers ever. I think it currently has about 140,000 citations, academic citations.
Yep. 140,000 other published papers have worked from this one novel argument. And it's all pretty technical.
Generative pre-trained transformer architectures, what we are calling in the field as GPTs, generative pre-trained transformers.
So if you have ever wondered why ChatGPT is called that, what those letters GPT stand for, it goes back to this idea in this one viral scholarly paper, which it actually had a pretty catchy title for a work of scholarship. It's called Attention is All You Need. Though the working title before that was a little bit more what you'd expect, Transformers, Iterative Self-Attention and Processing for Various Tasks.
It's essentially telling us that you need to pay attention of all the tokens or words that comes before and that are likely to come after a particular word in order to be able to make the best sense of this word. So you pay attention to the surroundings of each word to be accurately predicted. And there's a really beautiful mathematical equation behind these attention mechanisms, but there is really not much point in getting into deep details of this. What really matters here is that these attention mechanisms are bringing in a significant amount of advancements to what we are calling in the field the multi-layer perceptrons, so these neural networks, and they have been working very well in recent years.
That's Mutlu Cukrova, a professor of learning and artificial intelligence at University College London. I'll admit I tripped over his last name when I first got on a Zoom call with him.
It is read as Kukurova, which sounds a bit like crazy cuckoo, but...
Mutlu is one of the many scholars who has cited this paper, Attention is All You Need. And his focus is how to best use these new generative pre-trained transformer models in education. He's citing it because he's concerned that in a rush to try out ChatGPT and other new AI models, educators might be missing something crucial about what's going on in these GPTs.
I think a lot of my colleagues approach to these kind of questions from a very pragmatic point of view about, these tools are out here. How do we make sense of them? How do we use them? How do we utilize them in educational contexts? But in order to be able to appropriately and fundamentally address these kind of questions, we need to take a step back to be able to identify the extent to which these tools are differing from existing traditional information and communication technologies.
There's never before been a technology dropped into educational settings quite like these GPTs. Basically, teachers are putting AI tools in the classroom that even the programmers who designed them don't know exactly what they're going to do or say next, which is kind of astounding when you think about how much effort has traditionally gone into things like textbook standards in K-12 schools and the careful editing on college textbook editions to make sure things are accurate and effective for as many students as possible. So Mutlu argues that when we talk about AI in education, we need to be clear on how this new so-called intelligence works and how the way AI thinks is different from how humans think. In fact, he has a paper of his own with a proposal of how to better pair GPTs and humans in the classroom. Welcome to Learning Curve, a new podcast that looks at what it means to teach and learn in the age of generative AI. I'm your host, Jeff Young. I'm an independent journalist exploring the future of education. This is the first episode of Learning Curve, so first, just a bit about what the plan is. I have been covering the intersection of education and technology for a long time. I started back when it was the internet. That was the shiny new technology that colleges and schools were wrestling with what to do about. Most recently, I hosted the EdSurge podcast, which was about the future of learning. I produced more than 300 episodes of that over 7 years, so that was quite a run. This new podcast continues that tradition, but diving deep into AI and what this fast-moving technology could mean for education. The goal is to inform a conversation about what it means to learn and teach, and to sort out what learning needs protecting in this AI gold rush. Because generative AI and all of the GPTs inspired by that viral research paper, they raise profound questions about things like what it even means to be intelligent. And there are also practical questions, like how do you measure what a student knows when a chatbot can do the homework or write an essay for them in largely untraceable ways? Plus, there is the broader question of what schools and colleges should do differently as AI changes the world of work and many other aspects of daily life. Each episode is going to ground these bigger questions in a specific situation playing out at a college or a high school, or explore an argument in some new book or a new scholarly paper. These days, I am out on my own as an independent producer and freelancer, so I'm going to be asking for listener support to keep this new show going. One easy and free way to support the show is just to follow this podcast on whatever app you are listening to right now. If you do have a minute, a review would also be a huge help. I know all kinds of podcasts say, follow the show, but this really does help the algorithms kind of weight whether people care. So it's a big deal. You can also become a paying member of the show and get bonus episodes that go deeper into the topics that I'm exploring. You can find out more about that on learningcurve.fm. That's the show's website, learningcurve.fm. I'm excited to be back on the microphone talking with you and to be interviewing folks shaping education in this time of change and, let's face it, a lot of upheaval. I do want to point out that I did this interview that you're about to hear way back in January. So, and this is saying it lightly, there's been so much going on since then in education and in AI. But this conversation is really exploring big picture issues. And I feel like the conversation that you're about to hear is even more important with all the turmoil going on in higher education these days. And I think there are just more people kind of jumping in and trying to get a handle on what is AI and how should it be thought of in terms of education. Okay, so back to generative pre-trained transformer architectures, GPTs. As anyone who has followed my work over the years knows, I'm super interested in the narratives and metaphors that we use when thinking about educational tools. And that is something that was clearly on the mind of my guest this week, Mutlu, as well. I first discovered the scholar's work based on a super interesting paper that he published last summer. It's called The Interplay of Learning, Analytics, and Artificial Intelligence in Education, a Vision for Hybrid Intelligence. Hybrid intelligence. In that paper, he proposes a way to productively think about blending AI and human intelligence when it comes to education. So I was excited to start our conversation there. First off, it seems like you are thinking through how we think about the way AI fits into learning matters, the way we conceptualize it. Is that fair to say?
Absolutely, yeah. I mean, that's a really interesting question, isn't it? Because, and maybe in order to be able to give a brief introduction, it would be useful to start by saying a couple of sentences about the essence of these large language models.
I was going to ask you. Yeah. So in other words, it's important to understand how they think, the language models operate. What's that? I feel like people are game for a refresher, even if they're up on AI.
Indeed. I mean, I guess it would be even appropriate to start by saying that they don't really think in the way that we think as humans.
Yeah, I put it in air quotes, but people can't see. Right. I said think, but that's even anthropomorphizing them.
Exactly. As many of the historic attempts on talking about intelligence, we really struggle to talk about intelligence in any other way than we talk about human intelligence. But actually, artificial intelligence is a very different kind of intelligence.
So one big thing about these GPT models is they're constantly guessing the next best word or phrase or token to use based on this algorithm. But there's more to why they work than just that.
On top of these GPTs, like all the ChatGPT and all the BERT kind of transformer architectures, OpenAI kind of companies have recently also discovered the value of using human feedback in the continuous training of AI algorithms. So on top of these pre-trained models, ChatGPT kind of tools are using an approach called reinforcement learning with human feedback.
Reinforcement learning with human feedback. Okay.
Exactly. So this is an approach where you would present a particular prediction to people and ask people if they like this particular prediction, or present them two different predictions and tell them, well, would you prefer this response or this response?
So they're checking it against a human.
Exactly. Sometimes when you get these kind of OpenAI's ChatGPT responses, it actually proposes you two options and then it asks you to choose. So when you choose, it actually takes this feedback into the reinforcement learning model's account. So next time you ask, it improves the performance of the model accordingly. They also use these kind of reinforcement learning with human feedback approaches to be able to patch the existing biases or challenges or limitations of these models. For instance, there are many people working in these companies, usually recruited through third parties, and their entire job is what is called as red teaming. So they are pushing the model to make mistakes or towards more gender insensitive issues, towards more racially insensitive issues. So you push the model so that whenever it makes mistakes, you can provide human feedback that this is a racist response so that this can be patched in the long term.
That seems, that approach, I definitely have heard what you're talking about, this red teaming model. It does feel impossible to get everything though, right? I mean, it's an interesting approach. It seems like it could get so that any average user would not hit upon horrible racist or sexist or whatever material. But how could you get it all?
Yeah, you can't. I mean, basically, you can't guarantee that this will never be the case. But the scale at the moment of these companies is literally in the thousands of people working on these kind of tasks. So you can really improve the model performance significantly. But
so if you have constant there are humans out there clicking right now. Is that what you're telling me?
Yeah, exactly. Well, actually, this is a continuous training. So, and after this model building, you do this continuous training of reinforcement learning with human feedback. So that
I see.
Progress. And once you feel like this is you reach a comfortable level of accuracy, comfortable level of bias, because it's not like these are never biased models, but you feel like, okay, I can cope with this amount of bias, then they are released into the world. So the point that I usually make when I talk about these kind of AI techniques is that this is a really impressive, from a technical point of view, technology. I mean, we made very significant progresses, but in essence, this is problem solving without really understanding the problems. It's a design kind of intelligence. So you tell these models that these are the kind of things that you should be predicting, and then trying to minimize the loss function of these predictions. The model does not really have a genuine understanding of the problems or predictions that they are solving and they are generating. It's a designed intelligence to optimize towards a particular solution that we as humans think as appropriate solutions or appropriate outcomes. And because these models have no a fundamental understanding of the solutions that they are proposing. They might also be proposing many solutions that are not well aligned with human values. Or they might be proposing solutions that have significant societal and ethical implications, and they wouldn't necessarily consider these kind of aspects in the proposed solutions. It's a design intelligence. It's very impressive, extremely powerful, but it's a design intelligence. But when we talk about human intelligence, it's a very different kind of intelligence, because human intelligence is an emergent intelligence. It is the product of millions of years of evolutionary pruning that leads towards a very flexible intelligence that also has significant limitations and vulnerabilities that are embedded into the evolutionary process.
Like what's a good example of one of those limitations, just to make sure I understand that?
Of course, I mean, I can give at least a couple of really straightforward examples. One of them is the fact that we have episodic memories because humans have very limited bandwidth in information processing compared to these technologies. A human bandwidth of information processing is very limited. Therefore, we have evolved into developing memories that do not necessarily record everything in a particular order, but tries to remember particular specific moments that we consider as important. For instance, if you go out for a coffee, or if you went out for a coffee in the morning, for instance, and if I asked you, well, do you remember the fourth male person that you saw on your way to grab a cup of coffee? You would really struggle. You would really struggle to remember exactly who this person was. But if I ask you, how was your experience of going for a coffee in the morning? You would remember certain things. Maybe you would remember that you saw an attractive woman on the way. Maybe you would remember that you didn't have change with you and you used your card. Like, you would remember certain moments, but you are not really recording the entire experience. Whereas with an AI or information communication technologies in general, because bandwidth is not an issue, you can actually process all the information.
Like everything, like details.
Exactly, in detail. Or there are even simpler examples of these. Like, you can ask people, oh, do you remember the alphabet in an order? And they would be easily regurgitating this information to the A, B, C, D, E, F, G. You can even sing the song about it. But if you ask people, would you like to, or can you actually tell the alphabet backwards? Many people would struggle, even though from an information point of view, from the theory of information, it's exactly the same amount of information.
We take it for granted the way we think, and we think about intelligence as human. And scholars say the human brain turns out to have tons of advantages for the world that we humans live in. But the scientists out there building computing tools, they don't have to follow the same approach as our biological brains do, which, after all, have their downsides. Like, I just can't quickly say the alphabet backwards right now. Z, Y, X, W. I don't really have the right song pattern for it. I can't do it.
We have certain limitations and vulnerabilities of our way of thinking that are the direct products of our evolutionary processes. And there are 5 significant phases in most of the educational neuroscience literature about these evolutionary processes, that each one of them has significant advancements. If you're interested, I can tell you about these 5 different phases as well. But big picture point here is that these evolutionary breakthroughs and processes have led us humans to develop a kind of intelligence that is an emergent intelligence of the product of evolution, whereas with AI, we are designing intelligence, and they have very different kinds of intelligence. That is not to say that they are more intelligent than us, or I'm really sorry to say that, but we are not really more intelligent than AI. It's just it's just different kinds of intelligence. So there are many things that humans can do much better than AI, and many other things that AI can do much better than humans, which brings us towards this idea of how do we create complementarity, which is my area of interest particularly.
So the researchers building these new AI tools are essentially building a new kind of intelligence that could possibly complement our human intelligence.
Maybe just give me a flavor of those 5 phases of intelligence that you just without spending too much time. But what are the bullet points on that?
Sure. But in the literature, usually colleagues talk about 5 groundbreaking advancements. There is a bit of a debate about the extent to which these could be considered or how clear-cut these are. But
in human intelligence evolution.
In biological intelligence in general.
I see. Oh, interesting.
First breakthrough of biological organisms is considered as this idea of being able to make sense of stimuli around biological organisms, to be able to categorize them as good stimuli and bad stimuli, so that we can turn towards good stimuli and avoid a bad stimuli. And that itself has enabled organisms to navigate their environment by categorizing these stimuli into 2 different categories. And then this was followed in evolutionary chronological order by this capability of reinforcing, which is this idea that you repeat particular behaviors that lead towards the positive outcomes, and you avoid those behaviors that lead to negative outcomes. This repetition and reinforcing of positive outcomes is the second major breakthrough, because it allows organisms, biological organisms, to learn through trial and error, essentially. Because
you try. We're the world is training us. Like we're kidding.
Exactly. And all animals have these kind of capabilities of trial and error, all biological organisms. And then the third major leap perhaps can be considered as this idea of simulating reality. And this is only allowed by neocortex development.
So not all biological organisms have this one.
No. So mammals have neocortex developments that allow them to simulate reality. So rather than acting upon their stimuli, mammals have the capability of simulating and thinking about what would have happened if I have acted on a particular stimuli. So without acting upon this stimuli, you can actually make certain decisions and learn through simulating reality. This is extremely important because mammals actually can do this to be able to learn counterfactually. All of this thinking about, if I could have done this, I would have done that. Extremely important breakthrough itself. And there are fantastic experiments, for instance, with mice and how mice can think about avoiding smaller amounts of food in particular experiments if they know that this avoidance can help them reach out to bigger rewards or bigger amounts of food. Because this way of thinking that, if I avoid this small food, I will be rewarded with a bigger food, requires you to think and simulate a future reality that you have not really acted upon, and that requires neocortex development.
I don't think we usually think about our environment as training our brain. But that is essentially what has happened over the roughly 300,000 years of humans on the planet.
And then there comes the mentalizing, or this ability of modeling one's own or other people's mind when they are making certain decisions. For instance, when you saw me, when you heard my accent, when you looked at my credentials, you had a model of me in your mind, right? When I joined this discussion, and you started asking me questions based on this model. You don't just say the same thing to everyone.
Right.
The same thing, because I came here with a model of you, as well as a model of what you might be thinking about me. So there's like a meta model there as well. But this capability of what is called in the literature as theory of mind is a very specific feature of primates, because that allows primates to learn through observations. So you can see chimpanzees, for instance, observing their parents on how to use a particular tool. And not all animals can do this because that requires significant amount of a theory of mind. And then final development is oftentimes considered as this capability of speaking. So the idea that you do not necessarily need to reinvent everything as an individual, but you build upon the generations of intelligent humans who have come up with various ideas and written and wrote these down, and then you can read these. So I didn't need to reinvent gravity's mathematical foundations because it was already discovered when I started studying, and that's only possible because we have language that we transfer ideas. So these kind of 5 major breakthroughs actually lead towards a particular type of intelligence that is unique to biological intelligence. And I don't really think that we can ever reach the same level of intelligence with artificial products, because to me, for an AI to be able to reach this level of intelligence, the AI itself has to go through the same irreducible steps of evolution. It is not only about the strengths of this intelligence, it's also about the weaknesses of this intelligence. And that's not really an ideal thing for an AI to do.
It's interesting because let me just sum up what you just said, which is fascinating, is if we somehow would simulate and do an AI that was trained evolutionarily, the way biological brains have evolved, we would end up with something. Maybe it's not even theoretical possible, but if we did it, then it would not be able to do the alphabet backwards very well anymore. Whereas right now, the built AI has some strengths that it can do that we cannot do because of the way our brains were trained. Is that fair?
Exactly my point. And why would we need to do this anyway? There are like 8 billion people already with significant intelligence out there. Why would we want to create yet another intelligence that is out there that is same as ours? I don't really see the point.
That's so interesting. Yeah, I like the why of if we were going to clone a human brain, for what? I mean, I'm sure people probably have thoughts. I mean, people always, right? It's isn't the history of robots people, servants to help us or some thing? But then even fair to ask, why? But why would we? There are humans that we can work together with. It's a big question, actually.
Look, I understand from a scientific investigation point of view, because we are all fascinated with our own intelligence. So trying to build something similar does make sense from a scientific investigation point of view. But oftentimes, if you actually listen to the rhetoric of why people would like to build something like this, it boils down to the ideas of people, what they would be doing if they had the power over another human being, and that's kind of what they are trying to achieve, right? And these are not always very pleasant or good for society kind of acts. They are often power dynamics of pushing one's own ideology over another one. This has been happening in the past in various communities, and I think to a certain extent this is what is happening. So the big point that I would like to perhaps make here is that AI being different than human intelligence is not necessarily a bad thing, and it might actually be a good thing that it is different than human intelligence.
In a practical way, even just having, people concerned, and we've had episodes about worry about replacing jobs, with a artificial intelligence. Well, if we build it so that it is exactly like the human brain, it seems inevitable that it would replace biologically humans in jobs. Whereas what you're saying is if we design from the get-go an AI that is meant to be a sort of amplifier for the human mind, then these can't be, these are less likely to just put people out of work and are more likely to have amplifying trends. Is that fair?
That is fair. And frankly, this job replacement discussion is a quite interesting discussion as well, because oftentimes these kind of fundamental differences between AI and human intelligence essentially causes significant implications on what kind of jobs and tasks can be replaced with AI as well. For instance, oftentimes, if you look at the history of automation, those tasks that were immediately replaced with industrial revolution or automation in general are the kind of tasks that are so much mechanized in the way that they are implemented that whether a human does it or an AI does it should not really make a huge amount of difference. So let me clarify this a little bit more. Maybe it wasn't very clear.
So similar what you're saying there. Okay.
So maybe we can think about the call operators, right? If you look at the job of a traditional call operator,
Okay.
these are oftentimes people with a very clear set of scripts, very clear set of responses to certain types of inputs. They very rarely go out of their particular structured responses. So they are extremely mechanistic jobs. And at some point, they become so mechanistic that they are very easy to be replaced with AI. Brian Christensen has a fascinating book about this. I think it's called The Most Human.
It is. I am fascinated. I think everybody out there should read The Most Human.
He has a fascinating book about this topic, and in which he talks about these pre-automation phase of certain jobs where the job is extremely mechanistic and it's actually inhumane not to replace it with AI. And these are the kind of things that we can very quickly and easily replace with AI, and this replacement is probably a good thing. But there are also certain other kinds of jobs that are automated with AI that actually comes from the reconceptualization of particular jobs. And these are very tricky to predict and mitigate the impacts of. The very good example of this, I think, is that when sometimes people talk about the replacement, they talk about this cars versus horses analogy. It's a very simple analogy, but it's very powerful. So just as cars are not direct replacements of horses, and cars are not really faster horses, AIs are not really smarter humans. I don't really know if that makes sense, but they are not really smarter of the same category of a thing like human intelligence, which actually means that when you think about cars and their introduction to the society, you do not really think about a replacement per se, but you think about reconceptualization of some of these constructs, like what is distance? What is a journey now? How much is far and how much is close for a human being? So all of these reconceptualizations require certain professions to be rethought.
I want to pause here because I did a vacation to Chicago and went to the Museum of Science and Industry. And one of my favorite things I learned or saw was a room with the kind of like prototype or like the examples of like moving from the horse-drawn carriage to cars. And there they were, like up on this, stage of like the different, you could see them. And some of the ideas for early cars were kind of crazy to us now, I think, because they look like they're so tied to the carriage idea. And they kind of transform as we go. And maybe that's not even the best analogy, but to see some of them, I'll have to put some pictures on the show notes, but like with cranks and like with the areas to sit on top, or like there were things they were like carriages, but then and sometimes I think there was a regulation where you still had to have them have the ability to have a horse hook up to it, even when they were, running on their own, because the police required that you have a ability to have this horse draw the thing because it's a carriage. So I think that's what you're talking about. Like, and eventually we evolved to a car, and it changed a lot of things about transportation and the way we think about getting around.
Exactly. And the way that we think about human connection as well. So this kind of reconceptualization is more or less what is needed in a lot of the AI applications in educational contexts or human development contexts, rather than thinking about what we have initially started in your question, replacing particular tasks of teachers or educators
or tutors or anything, right? Yeah.
Exactly. It's a way to, I guess, accelerate this very much needed rethinking in our education systems.
So, okay, let me just rephrase it again so I make sure I follow. So, in other words, in some of my coverage in a lot of press, there's this thing of like, will AI be a personal assistant? So it's now, like that's a job that we know what it is. It's a human job. Will it just do that? Will it be a tutor? Will it be a, like there's these literal metaphors, and in your mind, those metaphors are not helpful as something where it's like, wait a minute, what if you had a way to think about it as there's a new thing to do, but if you have this new tool and a human brain together.
Exactly.
So you can't just think of it as an assistant or a tutor.
I think it's very limited to think about. It's limiting for their capabilities, but it's also limiting for what we can achieve with AI if we only think about them through these analogies of assistants or a tutor. It is, as I said, this conceptualization of them having a very different kind of intelligence essentially has significant implications that are associated with this very much needed rethinking about what is the purpose of education, what is the purpose of human learning, and how it can be reconceptualized to a certain extent to be able to make the most out of these technologies as part of a human AI tightly coupled systems.
It feels to me like I've been watching the Marvel superhero movies in timeline order with my wife and kids, and it feels like there's this, the world has gotten this new alien technology, and now we have this challenge to figure out, is it going to be harnessed or used for things that are going to be like destructive. I don't want to make too flip about this at all, but it does feel like a big moment here.
Yeah, it is indeed. Although, it's actually fascinating because a lot of these kind of reconceptualizations and rethinking about education systems, it takes time and effort, and we need to digest a lot of these developments and technical advancements that have been happening. And usually the easiest way is to think about any kind of replacement because it's so much faster if you can just replace. It's like a plug and play kind of activity.
Well, and the internet was a history of that. I mean, a lot of things, although I guess you could argue, I'm sure people out there are like, no, but there are things with the internet that it was like, we'll have e-commerce and we'll have, like we'll just take the thing we've done and we'll put it on the internet. And in some cases that kind of did track and work.
It did, but look how much time it took to actually properly realize these. I think at the moment, unfortunately, with a lot of AI in education implementations, at least, we are rushing towards particular task replacements that are not necessarily very valuable for education. We have a lot of work with regards to what kind of tasks we could potentially automate, like fully automate with the help of AI. And there are very few tasks of a human teacher that can be replaced. And oftentimes these are the kind of tasks that do not necessarily require human intelligence. For instance, we have been experimenting a lot with AI-generated synthetic media because a lot of the pedagogical implementations these days require what we are calling the flipped classrooms, or recording a particular lecture and putting a video in advance of a classroom so that people watch it and they come to classroom.
The lecture as the homework, and then we use class time for other things, for more interactive. Yeah.
Exactly. And now this task is a very annoying task. I don't know if you have ever done this, but as a professor at UCL, I have been doing similar pedagogical implementations. And for 1 hour lecture or 20 minutes lecture recording, you might spend 5 hours in front of it.
Oh, it's annoying to make it. It's challenging to make the video production. Okay.
Absolutely. Very, very difficult to make these kind of things. And for a lot of the companies, large scale companies, for their employee training, these kind of materials are very difficult to produce because you need to pay a professional video creator to go to interview the expert and create all of this. It's a huge time and resource intense activity. So we have been experimenting AI-generated synthetic media, looking at if the same content is delivered by me recording my video in front of a screen, or human expert recording the video, versus the same content delivered with AI-generated synthetic media. And in our experimental results, we have shown that there is no statistically significant difference in terms of the learning gains, which means that you can actually learn the same amount, both in terms of memory recall and recognition, which are two major learning sciences dependent variables, the constructs that you would measure. So this is the kind of task, to me, that could potentially be fully automated with AI. And I have no problem with this.
So it's the production part of it, yeah.
Exactly. Or, some kind of material generation. So these kind of information retrieval tasks of a teacher. Maybe more and more educators will not need to create particular materials, for which they would have to pull information from various sources and synthesize it together. These kind of tasks I can see full automation to potentially work, but a lot of the other tasks are extremely difficult to be fully automated with AI. So we need to think about alternative conceptualizations.
I'm going to cut in here because as I listen back, I really wish I had stopped Mutlu here and pressed him a little bit more. Because, hold on a second, if I think about the implications of what he's suggesting, he's essentially saying that the type of work that he is fine to automate, to replace with this new kind of AI intelligence of GPT, is actually the kind of work that I do. It's the work I'm doing right now, in some ways. It's being the voice delivering information to an audience. In his case, the audience is students. And so he's saying he's fine with having a bot make an educational video for him that his students can watch before class, so he can spend class time discussing that material, which then he knows the students have learned through the video. So I guess in his scenario, the professor would be the one curating the material, doing the expert analysis, and even crafting the message. So maybe it's not a full replacement for what I'm doing here, but still, this seems like giving up a big part of what makes a professor a professor. The standing before students imparting hard-won expertise, in this case in a video. But I guess this isn't the part of the job that Mutlu personally sees as invigorating or key. At least not delivering intro-level or rudimentary knowledge. So, if I understand him correctly, it's that part of his job that he's okay to try GPT for, and then he can correct and make sure that this synthetic media, as he called it, that the bot makes is accurate. And so for him, a good use of what he calls hybrid intelligence is to have the bot do some video presenting and video editing, tasks that he considers a little tedious. And that leaves him more bandwidth to do what he enjoys, and what seems to him more human. I've been talking to educators about AI a lot this summer, both for this podcast and for some freelance articles that I'm doing for the Chronicle of Higher Education. And I want to share a pattern that I'm noticing. It's been a pretty consistent pattern. So much so that I've even started to jokingly call it a law of generative AI use. Let's call it the learning curve law of AI. Here is the pattern, and see if you think this is familiar. For any given person, the part of your job that you like the least and consider kind of boring, that's the part you're okay with passing off to a bot, even if the bot is flawed and takes some work on your part to correct. But here is the challenge. Not every professor agrees about which part of the job is tedious and kind of boring. For some professors and teachers that I've met, making lecture videos is exciting. It's a place for playfulness and a way to connect with their students, rather than something kind of boring. But maybe those professors hate grading papers, and so they would give that up in a heartbeat to GPT, especially for rudimentary assignments. The result is that even among professors who say that AI should not be used for everything in education, there's disagreement over what this new kind of intelligence can appropriately be used for. And I suspect this might be true even more broadly. After all, AI seems to be able to automate so many language-based tasks that people can't agree yet on which of those tasks are so human that they need to be protected, and which tasks are just kind of boring and tedious. Anyway, that's my take. And I did press Mutlu a little bit on this. And he offered more about how this different way of thinking that AI does could help human teachers in new ways beyond just doing tasks for them.
Basically, I want to make sure I leave people with this bigger, like another kind of way to think about the hybrid model, because that example helps, but I guess I'm still thinking about it like where, if we're not thinking about a horse carriage to build with this, what is a way in which AI, these large language models, as you described them, could amplify intelligence and be thought of conceptually as like a partner with a human brain?
Well, I mean, that's $1 million question, isn't it, Jeff? And I usually, when I talk about these conceptualizations, I tend to give many examples of attempts from the literature with regards to this replacement and talk about the limitations and challenges of it. Talk about more traditional AI techniques that are driven by rule-based systems, or more transparent AI techniques, or literally straightforward learning analytics approaches where you would build a computational model of a particular learning behavior and then present these models back to the learners or back to teachers and expect them to change their representation of thought about what good looks like in a particular situation. For instance, you might create a transparent model of students' verbal and nonverbal interactions in a small group, and then generate visualizations of a computational model that shows who follows whom in the discussion, how much each individuals are speaking and contributing, and generate these kind of visualizations, computational models, as a visualization to be internalized by humans. And then you expect humans to change their representation of thought about what they should be doing to raise their awareness of their own actions and improve the accountability.
That's almost like training tape for a professional athlete.
For instance, that's a really nice analogy, actually. Of course, not all learning is performance-based, so you wouldn't necessarily focus only on very observable behaviors, but you can generate some observable behavior performance indicators as conversation opener between a human teacher and a human learner, because then they can start talking about this and interpret it. This kind of reflective thinking about computational models and performance measures that comes through computational approaches are extremely powerful. But I'm yet struggling still to see strong empirical evidence of us interacting with AI models leading us humans to become more intelligent after this interaction when the AI is not in the scene anymore. So there's a huge difference between amplification and augmentation. In my definition of augmentation, you can do so many things with the help of AI much better than you would be able to do without AI. For instance, a lot of my students are able to code much better, faster with the help of an AI model.
I see. Sure. Yeah, these Copilot type things to help you make computer programs.
Exactly. You can immediately run an error. You see what's going on. The model itself cannot code very well as most of my students can. Most of my students cannot code as efficiently as they can with the help of AI, so they can augment their capability. But my question is, can my students become better coders without AI after their interaction with AI? And this, I don't really see many examples of.
So maybe not. It's an unknown so far.
Exactly. So that's a kind of empirical question as well. And my worry is that even though they might be augmenting their capabilities when they are working with AI, through this interaction, maybe they are actually losing certain competencies, what I call in my papers is cognitive atrophy, because you rely too much upon the AI model and its existence next to you, that you might be offloading certain tasks to AI, that in the long term, you might be losing your critical competencies of being able to complete these tasks.
Without the AI.
Yeah. Have you seen this advertisement of Apple Intelligence? I talked about this issue at philosophical levels, at very pragmatic levels, and within the literature in papers. But I saw 1 minute advertisement of Apple Intelligence, and it actually makes my point very clearly. Have you seen these?
Yeah, which one?
The one that there is one very much bored employee playing around with the office objects around him and playing around with his seat and various pens, and then writes a very sloppy email and actually doesn't really make sense, the email. He uses weird words like tachinga and doesn't really mean anything, these words, and then uses Apple Intelligence to convert this text of an email to sound very professional email to be sent to his boss.
I tracked down that ad, and you probably have already seen it. The boss appears blown away by this email that the AI wrote for the inept coworker. You really have to see it visually for the full effect, but here's the boss's reaction.
The most capable individual to undertake this task. Please let me know your thoughts. Best regards, Warren.
Huh. So then the boss reads this email and thinks that, oh my God, Warren, the name of this actor, in this case, the employee, writes a fascinating email to be able to complete a very difficult task. So essentially, the employee deceives the boss to essentially be allocated to a task that he would not be able to complete on his own. To me, that's a very worrying future. At the end, the Apple Intelligence goes out and says, I am genius, and the song a song comes in, and the guy pretends that he's a genius, but he's not. He's an ignorant person who cannot pull together 5 words to write a meaningful sentence in an email to his boss. I don't want my students, our future, to end up in a situation that they cannot synthesize information from 2 sentences to write 1 email to express their ideas. I want to be able to do this regardless of their use of AI or not. So this is not a future that I am looking forward to. But it looks like some of these big companies are pushing this idea that if AI can do it, maybe we don't need to. Well, hang on a second. What are we losing here if we are if we are offloading our agency to these technologies. So that's one of my huge worries about the future, that we might end up as humans losing our own cognitive competence, assuming that AI will be able to do these kind of tasks for us.
And then the minute AI shuts off, we're useless.
That's one. But even if it doesn't shut off, then maybe you can think about the fact that human knowledge and competence is a holistic type of construct. Like what we were saying, our vulnerabilities and strengths are hugely intertwined. So losing our capability of, let's say, writing a particular email, or using our language capabilities in different contexts might actually have a significant impact on our other capabilities that we do not even realize yet.
It will evolve the human brain differently.
It might, and it might actually. It's like these architectures where you are pulling a significant pillar out, and you don't really know what would be the long-term implications of this pillar not being there on our cognitive architecture.
Like a load-bearing column in a building.
Exactly, and language and writing capability might well be one of these load-bearing columns. We don't know because there is no empirical evidence. And I'm not saying this is exactly the case. All I'm saying is that without evidence of impact, why are we rushing so fast?
What is your recommendation? Like, are we rushing too fast? And is this potentially to our detriment with education and beyond?
I think so, particularly if you think about the commercial interest in this space. I think all of these changes that we have just discussed should be human-centered. So prioritizing human intelligence and human competencies should be evidence-based, that should be driven by research studies, empirically showing the impact, positive or negative impact of a particular AI intervention before we scale these. And they should also be a product of strong stakeholder negotiations. It's not the decision of me as an academic, a professor at UCL, not a decision of X company who produces these products, and not a decision of an individual teacher, but a community level stakeholder discussion should take place before we make a decision with regards to the extent to which these technologies should be integrated in education for replacement.
Yeah. This is big stuff.
Well, sorry, it sounded a bit pessimistic, but I hope it is a wake-up call for all of us.
I guess that's the question is kind of how do we manage this period of change?
Indeed. Oh, and one thing that I am quite keen for people to think about is that most of the commercial tools as they are available out there are very likely to be particularly designed and developed for commercial interest and user satisfaction. They might not really be very useful for human learning, because human learning actually requires people to take a step back, do the reflections. It's difficult, it requires a lot more cognitive load.
It's exhausting to learn because it's pushing you.
Exactly. Like when we have AI models that we built in our own practice, for instance, with regards to essay writing support, let's say, okay?
Sure.
And these models would never give my students direct responses to particular questions. They would never draft content. They would make them think about, oh, that's an interesting topic. Have you thought about this kind of...
Yeah, you write it, not me. Yeah.
Have you thought about this evidence? Have you read this paper? So you can actually rag retrieval augmented generation and integration into these models, so to bring in relevant literature as well. And my students think that this is a lot more difficult to interact with than ChatGPT, because if you write ChatGPT, I want to write an essay on X, it would write half of the essay for you, if not all of it.
It's back to that Apple Intelligence guy just goofing off and putting in nonsense. Yeah.
Exactly. And I don't want my students to be there, Jeff.
Wow. I hope we talk again. I'm so glad we had this conversation. Thank you for joining our podcast today.
It's been a pleasure. Lovely meeting you, Jeff. Yeah.
I have had lots of time to think about this interview since I talked to Mutlu, and it has really stuck with me. Because it turns out many of the issues that he raises in his paper and in this conversation, they have become hot topics over the summer, especially as more and more AI models are released, and AI companies are making more of their products available free to students or building them into tools that professors are already using. With things moving this fast, it's worth stepping back to look at whether the bigger framework for using AI in education is really the most productive for students and for educators. What are the best ways to think about this new AI, this new kind of intelligence? It seems like a really good first step would be to get a better handle on what exactly this new intelligence is and how to best use it to not replace brains, but complement them. I would love to know what you think. Please send me some feedback or your thoughts to jeff@learningcurve.fm. That's jeff@learningcurve.fm. I might include some of the responses that I get in a future episode, so please let me know if you are willing to be named or if you'd rather be anonymous. This has been Learning Curve Episode 1. We are underway. Please follow the show by clicking follow on whatever your app is that you're listening to right now, and spread the word to anyone you think might like this. And please consider signing up for Learning Curve Plus to get bonus episodes. Just head to learningcurve.fm to find out details. This whole independent podcast setup is new to me, so please bear with me and have patience as I get everything up and running. I want to take a minute to thank some of the folks that advise me as I've got this podcast up and running, including Bonnie Stahoviak, John Warner, Maureen Kelleher, Jeff Salingo, Brian Brady, Zach Rosen, Rob McGinley-Myers, Brita Green, James Napoli, and Scott Smallwood. Thanks also to my wife, Leah Fable, an amazing journalist you should all be following on Blue Sky. Music this episode is by Kamaku, and our artwork is by Richard Natu. We'll be back in 2 weeks with a new regular episode of Learning Curve. Thanks for listening.